Hello. So today we're going to talk more about infinite limits and limits at infinity. The first one we'll work with is infinite limits. And so for our infinite limits, we're going to use sign analysis, using sign analysis to determine infinite limits for functions that are rational functions. For rational functions. Okay, so this is the first thing we're going to do, which is our infinite limits. So let's just start off with an example. And our example is going to be to find the limit as x approaches 1 from the right of 2x divided by x squared minus 1. So notice that if we factor the denominator, we'll have 2x divided by x squared minus 1 equals 2x divided by x minus 1 times x plus 1. So we can write this as 1 over x minus 1 times 2x over x plus 1. Now, as x goes to 1 from the left or the right, 2x over x plus 1 goes to what? Well, let's see here. The x is going to go to 1, and this x is going to go to 1. So our numerator is going to go to 2, and the denominator is going to go to 2, which is equal to 1. So what this means is that this portion, this fraction, is going to go to 1. So the behavior is the behavior, let's write this down. So the behavior of 2x over x squared minus 1 near x equals 1 is determined by the 1 over x minus 1 part. And this is because 2x divided by x plus 1 is going to go to 1 as x goes to 1. Okay. So now let's actually, and now we know that, as x goes to 1 from the right, 1 over x minus 1 is going to go to either plus or minus infinity. And now let's look at why that is. So if we have 1 over x minus 1, let's consider 1 over x minus 1 when x is close to 1. So this is what we're considering. Okay, so here's the thought. The thought bubble is that when x is about 1, x minus 1 is approximately 0. So x minus 1 is really small, equals some really small number. So then 1 over x minus 1 is going to be 1 over a really small number. And the reciprocal of a really small number is a really big number. Okay, so it could be, again, keep in mind this difference between magnitude versus direction. When we discuss when we say really big or really small, we're talking about the magnitude. We're not necessarily talking about the direction. So it could be really big. Negative 10 to the 8th is a really big number. It's really big in magnitude, but the direction is negative. Okay, so even though we're saying really big, really small, keep in mind that it could be positive or negative. Okay, so we know, so here's what we know so far. So far, we are expecting the limit as x goes to 1 from the right of 2x over x squared minus 1 is either going to be plus infinity or negative infinity. And now I'm going to show you a technique that will that will always help you to figure out whether it's plus infinity or minus infinity based on analyzing the sign of the function. And I mean SIGNE. So we're doing sign analysis. You're analyzing the sign of the function. So here we go. So we've got 2x over x squared minus 1, and here's what you do. So we've already factored that into 2x over x minus 1, x plus 1. So I'm going to make three number lines. 1, 2, 3. Now this first number line is going to take into account 2x, the sign of 2x. The second is going to take into account x minus 1, and the third is going to take into account x plus 1. So each factor, so 2x goes with 2x. Each factor gets its own number line, x minus 1, x minus 1. Okay, and then x plus 1, x plus 1. So now what I do here now is I figure out, so I'm just going to put the origin on each number line. When is 2x positive and when is 2x negative? So 2x is going to be 0 when x is 0. It'll be positive if x is bigger than 0. And it'll be negative if x is less than 0. Okay, so now let's do the same thing for x minus 1. When is x minus 1 equal to 0? When x equals 1. So I'm going to put a 0 here. Now x minus 1 is positive. So my first question I asked is, when is x minus 1 equal to 0? And then I put a 0 where x minus 1 equals 0. Then my second question was, when is x minus 1 positive? Okay, put plus signs where x minus 1 is positive. Now, x minus 1 is positive if and only if x is greater than 1. So I'm going to go over here and I'm going to put plus signs when x is greater than 1. And also x is negative. That's the last part. When is x minus 1 negative? And that part should be easy because if you've determined when x minus 1 is equal to 0 and when it's positive, then whatever is left is when it's negative. And now let's do the exact same process, use the exact same process for x plus 1. So x plus 1 is equal to 0 at negative 1. So I put a 0. X plus 1 is positive when x is bigger than negative 1. And x plus 1 is negative when x is less than negative 1. Okay. So now what I do is I'm going to combine all of this information into one big number line. So make this a little thicker. Now, here's how I combine it. I'm going to combine it like so, well, actually. So I'm going to bring down negative 1. I'm going to bring down 0, and I'm going to bring down 1. Okay, so I bring down all of the zeros of my number lines above. So this is negative 1, 0, and 1. Now, when for x equals 0, 2x over x minus 1, x plus 1 is equal to 0. Okay, so I put a 0 here. For x equals negative 1, 2x over x minus 1 to x plus 1 is going to be undefined. So I'll put does not exist. So I turn my graph to the side and I put, let's put in here, does not exist. And similarly, we'll get does not exist for x equals 1. Now in between, what I'm going to do is I'm going to figure out whether I put positives and negatives. So let's see here. So for x less than negative 1,
it's 9 o'clock.
I have, for x less than negative 1, let me try to show you how this works. So for x less than negative 1, we've got this, 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 right? So we've got essentially a negative number divided by a negative number times a negative number. So we've got 2x over x minus 1 times x plus 1 is a negative number divided by a negative number times a negative number. So that's going to be the same thing as a negative number divided by a positive number, which is going to be a negative number. So all here I've got negatives, negative, negative, negative. Now in between, let's change colors here. In between, so now I've got to figure out what goes here, right? What goes in between negative 1 and 0. So in between negative 1 and 0, I've got negative, negative, positive. Okay, so for x in between negative 1 and 0, 2x over x minus 1 times x plus 1 is going to be a negative divided by a negative times a positive. So that's going to be a positive. So we get plus, plus, plus. Okay. Now my next interval of concern is going to be from 0 to 1. Right? So for 0 to 1, I'm going to have positive, and that's negative, and that's a positive. So let me erase this here so we can get some more space. So for x between 0 and 1, 2x divided by x minus 1 times x plus 1 is going to be a positive divided by a negative times a positive. That is a negative, so this should be negative. And for the last region, which is greater than or equal to 1, I'm going to look up here and look and do my sign analysis. Okay, so we'll have for x greater than 1, 2x over x minus 1 times x plus 1 is going to be a positive number divided by a positive number times a positive number. Positive over positive, positive, which is going to give us a positive. So this is positive, 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 positive. So from here, I actually could do a bit with sketching. I could actually do a bit with sketching the graph because I know, let's see here. So if we wanted to, we could probably sketch the graph because we could say, or get a pretty good sketch because we know at negative 1, we've got an asymptote, right? Because it does not exist. And at 1, we've got an asymptote. And let's see here. So it's something that's negative. So it's negative. We've got an asymptote, so it has to look like this. Then it's positive. Comes down to 0. then it's negative, has an asymptote. Okay, and then it's positive. So we could say the graph, here's a rough sketch. Now for our purposes, we don't have to do the full sketch because recall that our goal is to find, what's our goal? Is to find the limit as x goes to 1 from the right. Limit as x goes to 1 from the right of 2x over x minus 1, x plus 1. Okay? And so what we did basically was we're now looking at, I'm going to use the pink here. If we're looking at this limit as x approaches 1 from the right, that means that we're looking at values here. So did you see what I did there? Let me put a zoom in window here. We're looking at values here. And as x approaches 1 from the right, 2x, so let me just write this in here. So as x approaches 1 from the right, 2x over x minus 1 times x plus 1 is always positive. Do you see? It's always positive. So what that means is that our limit has to be plus infinity. So let's go back. Remember how we said that so far the limit is equal to plus infinity or minus infinity? Well, we just found out that as x approaches 1 from the right, 2x over x squared minus 1 is always positive. So our limit has to be equal to plus infinity. Okay? So now it might seem like this takes a really long time, but it really doesn't with practice. So what I want to do is I want to show you how to do the sign analysis really quickly. So I'm going to do another example. And this example I'm going to do not explaining it as I go, not step by step, but to show you that it's a pretty quick process. Okay. So I'm going to do this second example here, which is going to be find the limit as x approaches 3 from the right of x squared minus 5x plus 6 over x squared minus 4x plus 3. Okay, so let's see here. So the first thing I'm going to do is I'm going to factor. So I'm going to say that x squared minus 5x plus 6 divided by x squared minus 4x plus 3 is the same thing as, now on the denominator I've got x minus 3, x minus 1. And in the numerator it looks like I've got x minus 3, x minus 2. Okay, so I notice that my x minus 3 cancel out, and I've actually got x minus 2 over x minus 1. So here's what I'm going to say. I'm going to say, so the limit as x approaches 3 from the right of x squared minus 5x plus 6 over x squared minus 4x plus 3 is the same thing as the limit as x approaches 3 from the right of x minus 2 over x minus 1. Notice that here the numerator is nice enough in other words, nice enough means continuous, right? And you're getting practice for your continuous functions. The denominator is also nice enough. The denominator is continuous. So we can just write this as equal to 3 minus 2 over 3 minus 1. using our limit laws. Because remember that the limit laws apply not just to two-sided limits, but also one-sided limits. So this is going to equal 1/2. Okay? So we go back here and we write our solution. This is equal to 1/2. Okay, let's do another example. I'm just going to go to a different page here. Another example, this will be example 3, which is going to be define the limit as x approaches 1 from the left of x squared minus 5x plus 6 over x squared minus 4x plus 3. Okay, so we say, but wait a minute. We just worked out and we just practiced. So we just showed that x squared minus 5x plus 6 divided by x squared minus 4x plus 3 is equal to x minus 2 over x minus 1. X minus 2 divided by x minus 1. Okay, so now what I'm going to do is I know that if I try to plug in x equals 1, so try to plug in x equals 1, we're going to get a problem because we're going to be dividing by 0. So we'd have 1 minus 2 over 1 minus 1. You say, oops, it can't divide by 0. Right? So that's a key that, that's a key that something is wrong. So we're going to end up with plus infinity or minus infinity. Okay. So now let's go to doing our sign analysis. So I'm going to I'll have 1 for x minus 2, 1 for x minus 1, and then 1 for them together. Okay, so here I'm going to put my x minus 2, my x minus 1, and this is going to be x minus 2 over x minus 1. So I go here let me actually move this down a little bit. Okay, that's better. Okay, so I'm putting in 0 for everybody here. Now for x minus 2, 2, x minus 1, 1, 0, 0, plus, 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 minus, 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 plus, 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 minus, minus, minus. And now 1, 2. So that'll be a 0. That'll be undefined. Plus divided by a plus is going to give me plus. Minus divided by a plus is going to give me minus. Minus divided by minus is going to give me plus. Okay, so if I zoom in, if I zoom in here, my issue is I want the limit as x approaches 1 from the left. Okay, so here, as x approaches 1 from the left, right, we'll have plus, 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 plus. So it must be plus infinity. Limit x approaches 1 from the left. Oh, I can just write it here. Equals plus infinity. So the first thing I did was I figured out, so let's go back and review. The first thing I did was I figured out that, so at this step right here, where I try to plug in, I figured out that it's going to be plus infinity or minus infinity. So this told me that it's either going to be, so my limit my limit will be plus infinity or minus infinity. Now, this step right here of doing the analysis splits it into, or this step confirms that the limit
is
plus infinity. Okay, let's do another example. So we're going to do example, what is this? This is now going to be example 4. And we want to find the limit as x approaches 1/2 from the right of x squared plus 11x plus 18 divided by 2x plus 1. Okay. So, let's see here. So, or actually, sorry, this should be as x approaches negative, let me put in here, negative 1/2 from the right. Okay. So, as x approaches negative 1/2 from the right. That's what this notation means. Okay. So pretty much with, again, I've got a rational function. So I have a rational function. I'm trying to take the limit of a rational function. And if I try to plug in x equals negative 1/2, I'm going to get some number. So let's see, let me copy. Okay, so if I try to plug in, I would get some number of negative 1/2 squared plus 11 times negative 1/2 plus 18 divided by 2 times negative 1/2 plus 1. So this is some number, doesn't matter, it's some finite number, divided by 0. I say can't divide by 0, right? So say, In this case, I know that I'm looking at my limit. So my limit is, this is as x goes to negative 1/2, is going to be plus or minus infinity. Another way to know it, so here's one way to make the conclusion. So in fact, let me kind of clarify what we're doing. So what we're doing overall is we're trying to, the first step is to figure out that you have plus infinity or minus infinity. So now this approach right here that I've been using, and this is the same approach kind of that I used here. I used it back here, right, which is to try to plug in. And I think I used it, did I use it here? I essentially used it here, right, where I looked at really big, really small. Here's another way that we can come to the same conclusion. And what's the conclusion that we're reaching is that it's plus infinity or minus infinity. Use that fact from class. Use the fact from class, which says if you have a vertical asymptote, that means that you have an infinite limit. So vertical asymptote implies infinite limit, right? So I could say, looking at this rational function, I know that I have a vertical asymptote at x equals negative 1/2. Therefore, I have an infinite limit. Okay, so either way, however you get to it, it works. Doesn't really matter. And now let's go back to computing. So our issue is going to be, so we need the limit as x approaches negative 1/2 from the right. So our issue is going to be, it's equal to plus or minus infinity. Is it plus infinity or is it minus infinity? So now, here's an easy way to tell. Okay, I'm going to do my, I need to factor. Let me see. I don't know if you can you tell that factors, can you tell that this, so we have x squared plus 11x plus 18 over 2x plus 1. Can you tell that this factors into x plus 2 times x plus 9 over 2x plus 1? So now I'm immediately going to make a little number line for x plus 2. I'm going to make a number line for x plus 9. I'm going to make a number line for 2x plus 1. And then I'm going to make my number line for my original function. So this is going to be x plus 2, x plus 9, 2x plus 1, and then x plus 2, x plus 9, divided by 2x plus 1. Okay, where is x plus 2? Well, everyone needs to have the same 0 just so we can be on the same scale. So x plus 2, so that means negative 2. So I'm going to make this I need to zoom in. So this will be my negative 2. I'm going to make this negative 9. So we've got 0, plus, 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 minus, 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 negative 9 plus, 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 negative, negative, negative. Now for 2x plus 1, this is the same thing as 2 times x plus 1/2. So I'm going to go to negative 1/2. Notice that it needs to be to the right of negative 2. So I'm going to make it even closer. This is negative 1/2. We'll have 0, plus, 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 minus, 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 minus. Okay. Now I'm going to put it all together. Okay. So at negative 2, it'll be 0. At negative 9, it'll be 0. And at negative 1/2, it'll be undefined. I'm approaching from the right. So I'm approaching from the right. So I'm going to be concerned about what's happening over here. And I'm going to look, and I see that I'll have plus. So from the right, I have plus times plus divided by a plus. So this should be plus. So this limit is going to equal plus infinity. Okay. Let's talk about the limit as, let's do another one. I want to do another example. Example 5. Which is the limit as x goes to 0 from the right of x minus 4 over x squared minus 3x. Okay, so I'm going to rewrite this as the limit as x approaches 0 from the right of x minus 4 divided by x times x minus 3. So I just factored the denominator. Okay. Now, we have a horizontal asymptote, so I'm going to use that fact from class. Using the fact from class, since x minus 4 over x squared minus 3x has a vertical asymptote, at x equals 0, the limit as x approaches 0 to the right, x minus 4 over x squared minus 3x, must be an infinite limit. Which means the limit as x approaches 0 from the right of x minus 4 over x squared minus 3x has to equal plus or minus infinity. Okay, now all of this, right, it takes a long time to write it out, but in my head, I am instantly making that connection. So it takes longer to explain it than it does for me to do that calculation. So this is essentially the step 1, is to figure out that I'm dealing with an infinite limit. Step 2 is to figure out if what I have is a plus or a minus. Okay? I'm going to show you yet another way to kind of do this. And what you're doing is essentially, in your head, you're thinking exactly the process that we had for doing the sign analysis by drawing out the number line. So here's what you do. So you say, let me here's what we want to do. We want to, let me copy this. Okay. I'm going to paste. Okay. So in your head, I'm going to write down what you think in your head. And some of it you'll write down too. It might be helpful. So here's what you say. So you say, I'm approaching x, I'm approaching 0 from the right. So that means that x is a really small positive number. Okay? So x is a really small positive number. So if x is a really small positive number, so if x is a positive number, then x minus 4 is going to be, so if x is a positive number and x is really small, so x is, and do you all know what this notation means? This notation, when I put this little squiggly here, it means approximately. So this means approximately. And the reason why this part is important is because for x minus 4, think about it like this. If x is approximately 0, x minus 4 is going to be a negative number. So x minus 4 is approximately negative 4. So it's a negative number. Right? Now, that is our numerator, x minus 4. Right? So what I'm going to do is I'm going to figure out for each component of my rational function, what's the sign? Okay? Now let's see here. What about the next one? Is going to be x minus 3. What's going on with x minus 3? X minus 3 is going to be approximately negative 3. So this will be a negative number. Okay? And then again, we've got x. So let's put it all together. So x minus 4 over x times x minus 3 is going to be, x minus 4 is going to be a negative number, x minus 3 is going to be a negative number, and x is going to be a positive number. Okay? So altogether, we're going to have a positive number. So this is whenever x is a small positive number. So that means that when we take the limit, so that limit, which we know is an infinite limit, x minus 3, we know that's going to be an infinite limit. Sorry, my handwriting is just horrendous here. Let's try that again. So I have x minus 4 over x times x minus 3. This must be equal to plus infinity, because when x is a very small positive number, this fraction, right, so this fraction is always a positive number, so our limit has to be plus infinity. Okay, so now just to recap, what did we do here? So we said I'm approaching 0 from the right. Now how do I know that I'm approaching 0 from the right? So let's see here, this part right here. I'm approaching 0 from the right. How do I know that? Because of this notation right here, right? The x approaches 0 from the right. That's what that means. Now, what about the second part? The second part says, so x is a really small positive number. Now, if x is a really small positive number, which means x is approximately 0, right? Really small. This is the really small. Then I figure out what happens with each of my products and quotients over here. So I've got x minus 4. And I say, well, what happens with x minus 4? Okay, x minus 4 is going to be a negative number. And I put that here, right? So x minus 4 is going to be negative. And then the next thing I look at is, what about x, right? Well, x is positive because we said that over here. X is positive. So x is positive. And then lastly, I look at x minus 3. X minus 3, okay, is going to be a negative number. So I have my negative number over here. The negatives cancel each other out, and I'm left with a positive. Okay, so this is a short way, it's an even shorter way of doing the sign analysis. Okay, so in your head, you don't necessarily have to graph the entire rational function. You can still figure out number one. So what are our, so like this would be step one. I need a different color because I want to emphasize this is step one, is to figure out that you have an infinite limit. And then step two is to figure out if your limit is plus infinity or minus infinity. And you can do it by analyzing the sign of the numerator and the sign of the denominator. Okay? And the first thing you always want to do is factor. So, right, I don't know offhand what x squared minus 3x, whether that's positive or negative. So I factor it into x times x minus 3, right? And so that's how you're essentially doing a sign analysis to determine the sign of your rational function, and that'll tell you whether your values are going to plus infinity or minus infinity. Okay. Now, the last thing I want to do is to give you some practice. So here's some practice problems. Practice problems, because practice makes perfect. Practice problems are, consider this, the limit as x goes to 0 from the right of x squared minus 9 over 2x squared plus 1. Consider the limit as x goes to 3 from the left of x minus 4 over x squared minus 3x. Consider the limit as x goes to 0 from the left of x minus 4 over x squared minus 3x. And consider the limit as x goes to 1 from the right of x squared minus 5x plus 6 over x squared minus 4x plus 3. Okay, and now after the great presentation that we had on infinite limits, you can check your answers by going to Desmos.com, graphing these rational functions, and then using the analysis by just looking at the graph to tell what the limits are. Okay? All right. And if you need more practice with this, I believe there's practice online with Paul's online notes. If you go to Paul's online notes, I believe there is practice on the for the common graphs section. And if there's just is to Google, so let's put or, and then I'm gonna go up here and say or Google um, graphing rational functions, or right, graphing rational functions, and you can practice computing limits because it's essentially a step in graphing rational functions, or you can Google limits of rational functions worksheets. Okay,